Hello, beautiful people! Today we will discuss how to solve problem number 10 from the final exam of International Baccalaureate program. This particular exam has been held in May 2016. The problem itself. We asked to find the x-coordinates of all the points on the curve y of x given by the function at which the tangent to the curve is parallel to the tangent at the point -1 and 6. Let's go to the whiteboard. The lines are parallel to each other if they have just the same slope. The slope of tangent line at the particular point we could determine as a value of derivative. So, our first task to find out the derivative of y function. The initial function is an exponential polynomial of the fourth order. To find its derivative, we will use the rule written in blue box. The derivative of the function is, you can see at the second row here. But we need to find out the value of this derivative at the particular point when x is equal to -1. So we plug in x equals -1 into the derivative function and get the value of -2. To find out all points where slopes of the tangent lines are just the same, we should solve the equation where the left-hand side is derivative function, but right-hand side has a value of -2. So, if we collect all terms on the one side, the final equation will look like this one. To find the roots of this equation, we will try to factorize the polynomial of the third order. We will use the factor theorem for the beginning. If we take x equals 0, we would get -3 equals 0. It's nonsense. But if we choose x equals -1, we will get the true statement. The left-hand side is equal to the right-hand side. So, according to the factor theorem, binomial x plus 1 is a factor of the polynomial. Let us divide by this binomial x plus 1. And we will get a quotient, the result of the division. After using long division, we would have 8 times x squared plus 10 times x minus 3 is a quotient, and we will continue to factorize it further. To do it, we will apply the probing checking method. We know that the equation of the second order would have 2 roots. So we will try to find 2 factors. The first term is 8x squared, and we can express it as a product of 4 times x and 2 times x. Let's use these factors as the first terms in both brackets. Let us look at the last term. It's -3. The sign is negative. It means that sign in front of the second terms in both brackets should be different. Negative times positive give us negative. 3 is a prime number. We can present it as only product of 3 and 1. So, after some probing and checking, we'll get 2 different factors inside the first and the second brackets, the product of which give us the initial polynomial of the third order. Then, let us apply the nil product rule. The product of 2 factors is 0, if at least one of them is equal 0 as well. So, the solution of this equation is x equal 1/4 or x equals -3/2. Let us collect all information together. We try to solve the equation of the third order, and we have presented the left-hand side as a product of three factors, each of them written inside brackets. At the point when x takes the value of negative 1.5 or negative 1 or 1/4, the value in brackets turns to be 0. Let us look at the picture. The initial function is a red curve. The blue curve is a derivative function to the red function. If we pick three values of x, negative 1.5, negative 1, and 1/4, we can see that the value of derivative are just the same, and the value is negative 2. So, tangent lines to initial red function have just the same slope and these points. So, we solve the problem correctly. There are other two points with x equals negative 1.5 and x equals 1/4, where the tangent lines have just the same slope and all three lines are parallel to each other. See you in next tutorial. Goodbye!